Welcome to Chemistry Academy, Fajandar High School and Junior College, Vahur. Now, student, in last videos, we have covered all basic concepts and some important concept of halogen derivatives like preparation, nomenclature, classification, okay, and physical properties of halogen derivative of alkyl halide as well as aromatic or aryl halides. Now in today's lecture we are going to start optical activity. Now for optical activity some basic concepts are important like stereoisomers, what is chiral carbon, then what is chiral molecule, what is optical isomerism, what are enantiomers, okay, and then we will come to our concept optical activity. Now in case of optical activity, before going to start this point, let me revise the part which we have covered in 11th standard, that is isomer. And what are the isomers? Compound having same molecular formula but different structural formulae. Compound having same molecular formula but different structural formula is called as the isomers. Now in case of isomers, there are two types of isomers, okay, structural isomers and second one is your stereoisomers. All part in 11 we have discussed. Structural isomers like position isomer, chain isomer, that are the structural isomers, okay, and second one was stereoisomer. So we will try to start our point from stereoisomerism. Stereoisomer or stereoisomerism. Now what is stereoisomerism? Or what are the stereoisomers? Isomers having same bond connectivity. What is stereoisomers? Isomers having same bond connectivities. अब same bond connectivities का मतलब होता है same structural formula is called stereoisomers and phenomenon process is known as stereoisomerism. What are the stereoisomers? Isomers having same bond connectivities means same structural formula called as stereoisomers and phenomenon is known as stereoisomerism. Now there are two types of stereoisomerism. One is your geometrical isomers and second one is your optical isomers. Now optical isomers we will discuss in optical activity. Related to geometrical isomerism अपने 11 में डिस्कस किया है. Now suppose I am writing here butene. See, this is the structure of your butene. Okay. Now in case of butene, suppose this one is my plane. Suppose this one is my plane. Okay, horizontal plane. Now with respect to this plane, two methyl groups are at the above, two hydrogen atoms are at the below. So when the same molecules, atoms or groups are at the same site, it is called as cis isomers. This is called as a cis isomer. So geometrical isomers are of two types. One is your cis isomer and second one is your trans isomer. Now in case of trans isomer, the same species, atom or groups are at the opposite side. So this is called as trans isomer, and these are the examples of stereoisomers, that is geometrical isomers. So there is a same bond connectivity, that is same structure but a different in arrangement of atom or group. Difference in arrangement of atom or group. So these are the geometrical isomers. Now our point is optical activity. Now for optical activity, the important concept which we have to discuss is chiral carbon. Now after stereoisomers, our next point is chiral carbon. Chiral carbon, or we can say asymmetric carbon. Chiral carbon, or it is called as asymmetric carbon. Now what is chiral carbon? What is chiral carbon? A carbon in a molecule. What is chiral carbon? A carbon in a molecule which has different adjustment or which has a different attachment of group or atoms around it is called as chiral carbon. For example, I am writing here 2-chlorobutane. I am writing here 2-chlorobutane. Now, in case of 2-chlorobutane, this one is my carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Now, to this carbon number 1, C1, carbon number 1, at 3 types hydrogen atoms are attached, and another side this group is attached, that is here CH, Cl, CH2, CH3. Means here the 4 atoms or group of atoms are not different because CH3 are the same. But when we will see the carbon number 2, come to the carbon number 2, that is C2. Now in case of C2, left hand side CH3 is attached, above Cl is attached, at the bottom we can show this hydrogen atoms, okay, and right hand side CH2 CH3, and CH2 CH3 we can write here C2H5. see here it is your C2, 2 plus 3 5. Now can I say this carbon is your asymmetric carbon or this carbon is your chiral carbon? Yes, the carbon in a molecule which contain 4 different atoms or group attached to it is called as a chiral carbon. मतलब ऐसा कार्बन जिसको जो 4 वैलेंसीज रहेंगी वो चारों भी वैलेंसी अलग रहेंगे. जैसे यहाँ CH3, H, Cl, C2, H5, and this chiral carbon it is represented by styrene. It is represented by styrene. So this is important concept for optical activity, that is chiral carbon. So what is chiral carbon, student? A carbon in a molecule which carries 4 different atoms or group is called as a chiral carbon. Now after chiral carbon, try to remember this example, 2-chlorobutane. Now here CH2, 2 hydrogen atoms are attached, matlab this is not asymmetric carbon, chiral carbon. CH3 matlab already 3 hydrogen atoms are attached, so this will not your chiral carbon. So only carbon number 2 is a chiral carbon, okay, or this chiral carbon it is called as asymmetric carbon. Now after chiral carbon, our point of discussion is chiral molecule, and from here we will start the concept of optical activity. Okay, now my next concept is chiral molecule. Student, if a molecule contain chiral carbon, asymmetric carbon, if a molecule contain chiral carbon or asymmetric carbon, such molecule cannot be superimposable. Such molecule cannot be superimposable. Meaning बताता हूँ मैं. Okay, such molecule cannot be superimposable perfectly on its mirror image, and such molecule is called as chiral molecule. Let me revise, and with one example मैं इसको explain करूँगा. What is your chiral molecule? If a molecule contain asymmetric carbon, if a molecule contain chiral carbon, in such molecule cannot be superimposable perfectly on its mirror image, and such molecule is called as a chiral molecule. Now before going to start the example of chiral molecule, मैं आपको 2 points बताता हूँ. One is your superimposable and second concept is your non-superimposable. Second concept is your non-superimposable. Now what is the difference between superimposable and non-superimposable? If any object fit perfectly into one another is called as superimposable. Suppose I am taking these 2 glass. मैंने ये 2 गिलास लिया. Okay, 2 गिलास लिया. Now these glass are perfectly fit into one another. Glass are perfectly fit into one another. It is called as superimposable. It is called as superimposable. Glass are perfectly fit into one another. It is called as a superimposable. Take your chairs. 2 chair ले लो. That chair can be fit into one another परफेक्टली एक दूसरे में बैठते हो, दैट इज द एग्जांपल ऑफ योर सुपर इम्पोजेबल. नाउ कम टू माय two hands. One is your right hand and second one is your left hand. When you will observe the left and right hand, you will identify my left and right hands are like object and its mirror image. Object and its mirror image. या मेरे right hand को मैं mirror के सामने रखता. Take your right hand in front of mirror. You will get image like this. So this one is your object. ओके एंड दिस वन इज योर मिरर इमेज. अब जब ऑब्जेक्ट और मिरर इमेज को मैं जब चेक करूंगा, नाउ दिस कैन बी फिट एग्जैक्टली, ये एक दूसरे पर फिट बैठता? नो. सी द पोजिशन ऑफ थम्स एग्जैक्टली अपोजिट हो रहे. सी द पोजिशन ऑफ फिंगर्स, ये भी क्या हो रहा है? एग्जैक्टली अपोजिट हो रहे. सो ये इसको अपन बोलेंगे नॉन सुपर इम्पोजेबल. Two hands are example of non-superimposable. See, this one is my object and this one is mirror image. ये एक दूसरे पर फिट नहीं बैठते. That thumbs are at opposite direction. अगर एक दूसरे में फिट बैठे तो उसको अपन क्या बोलेंगे? Superimposable. And if not, then it is called as a non-superimposable. So my two hand, it is the example of non-superimposable. Glass, chair, it is the example of superimposable. Now my concept was chiral molecule. और मैंने डेफिनेशन क्या बताया chiral molecule की? क्या if any molecule contain chiral carbon, in such molecule cannot be superimposable on its mirror image, and such molecule is called as chiral molecule. Take the example of 2-chlorobutane. अभी अपने यहाँ लिखे थे example of 2-chlorobutane. Student, now in case of 2-chlorobutane, see this one is my carbon number 2. Attached here C2H5, that is ethyl group, then CH3. Okay, now then next part, okay, attach there CH3, then next part is your hydrogen atom, okay, and last part is your Cl. Last part is your Cl. Now this example is given to you and it is the stereo structure of 2-chlorobutane. It is the stereo structure of 2-chlorobutane, or this structure we can also manage in this way. See here, now this one is your CH3, this one is your Cl, and this one is your C2H5. Now this is the stereo structure of 2-chlorobutane, and now in this structure this carbon is asymmetric carbon or chiral carbon, and it is represented by a steric. It is represented by a steric. Just put mirror image, just put a mirror. अब ये स्ट्रक्चर को मैं मिरर के सामने रखूंगा. अब जैसे इसको अपन मिरर के सामने रखेंगे, वी विल गेट इट्स इमेज. अब इसका इमेज कैसा आएगा? नाउ सी हियर, दिस इज योर asymmetric carbon or chiral carbon. Now this group is your CH3, this one is your Cl. Okay, now this part is your C2H5. Okay, C2H5, and this part is your hydrogen atom. So now in this case, one is your object and second one is your mirror image. Now see here, 2Cl, then C2H5 and hydrogen atom and CH3. Now this is your object and this one is your mirror image. Now in this case, this normal line or normal bond indicates that atoms are in a plane. Normal line and bond indicates atom are in a plane. Now this dotted or broken line, it is called as dotted or broken line. This is called as thick line. अब ये dotted और broken line क्या indicates करता है? That atoms below the plane. थिक लाइन क्या इंडिकेट करेगा? That atom above the plane. वो एटम कहाँ आएगा? Above the plane या in front. और dotted line क्या इंडिकेट करेगा? Below या back side. Now this we can show by using our model. Now see, this green part, it is the asymmetric carbon. Now this green part is a asymmetric carbon. Suppose red light, this is our C2H5. Red bond, this is our C2H5, and hydrogen, it is blue bond. Hydrogen, it is a blue bond. When you will see this structure, in this case, these two yellow colored are normal bond, that is in the plane. These two yellow colors are normal bond. Now this thick line, see front side, broken bond, dotted line, that is blue color, it is back side. So this is the structure. Here C2H5 at the front side, here blue color, it is at the back side, and two yellow colors CH3 and Cl are at the in the plane. So this is the structure of 2-chlorobutane. Now in this structure, just take this mirror image and put on it. इसको उठाओ और ऑब्जेक्ट के ऊपर रखो. अब जैसे रखेंगे आप लोग, it will be superimposable or non-superimposable. Now take this and put on it. हाइड्रोजन और Cl एक दूसरे पर फिट बैठेंगे, Cl एंड हाइड्रोजन एक दूसरे पर फिट बैठेंगे. सो दिस मॉलिक्यूल विल बी नॉन सुपर इम्पोजिबल. ये मॉलिक्यूल क्या हो जाएगा आप लोगों का? नॉन सुपर इम्पोजिबल. एंड दिस मॉलिक्यूल इज कॉल्ड एज अ कायरल मॉलिक्यूल. हमेशा याद रखो, अगर मॉलिक्यूल में कायरल कार्बन रहा, डेफिनेटली its mirror images, object and mirror images will be non-superimposable, and such molecule will be chiral molecule. So our point of discussion, optical activity. So far we have covered stereoisomerism, chiral carbon and chiral molecules. इसमें ये point important है, what is superimposable and what is non-superimposable. अगर एक दूसरे पर fit बैठ रहे तो superimposable, and if not then it is not superimposable. Now I hope up to here you have understood what I have taught to you. So what is stereoisomers? Isomers having same bond connectivity, such isomers are called as stereoisomer. Now same bond connectivity matlab same structural formula. There are two types of stereoisomers. One is your geometrical, cis and trans, and second one is your optical isomers that we will try to cover. Now what is chiral carbon or asymmetric carbon? A carbon in a molecule which has four or which carries four different atoms group to attach to it is called as chiral carbon. Now what is chiral molecule? If the molecule contain chiral carbon, in such molecules cannot be superimposable perfectly with its mirror image, and such molecule is called as chiral molecule. अब cannot be superimposable मतलब वो क्या रहेगा? Non superimposable. Now student, after this chiral molecule, my concept is optical isomerism. Optical isomerism. Now what is optical isomerism? Our point number 4. Our point number 4 is optical isomerism. Now what is optical isomerism? The stereoisomerism in which isomers have different spatial arrangement, in which isomers have a different spatial arrangement of atoms group around a symmetric carbon. What is optical isomer? किसको बोलेंगे अपन optical isomers? The stereoisomerism in which isomers have different spatial arrangement of atoms or group around a symmetric carbon. अब different spatial arrangement of atom or group around asymmetric carbon, chiral carbon. See here, this one is my chiral carbon. अब इसको अपन ने जो 4 atoms attach किए वो different attach किए. 2 are in the plane, one is above the plane or at the front side, one is above the plane or at the front side, second one is below the plane or back side. Now this is called as optical isomers, and process is known as optical isomerism. So what is the optical isomerism? The stereoisomerism in which isomers have different spatial arrangement of atoms or group around a chiral carbon. below the plane, above the plane, in the plane. So below the plane या back side के लिए अपन क्या यूज करते हैं, broken line, dotted line. And above the plane या front side, above the plane का मतलब होता है front side, उसके लिए अपन क्या यूज करते हैं, thick, solid बोलते हैं उसको, solid line, thick line. Okay, and these are called as the optical isomers, and phenomenon is known as optical isomerism. Now related to optical isomerism, our next and point number 5, it is given enantiomer. Point number 5, it is given enantiomers. Actually, enantiomers are optical isomers. Enantiomers are optical isomers. The optical isomers, yeah, isomerism in which object and mirror image are non-superimposable to each other are called as enantiomer. What is enantiomer? The optical isomers in which object and mirror image are non-superimposable to each other are called as the enantiomer. Non-superimposable, like my two hands are the best example of enantiomer. देखो ये सुपर इम्पोजेबल है या नॉन सुपर इम्पोजेबल, एग्जैक्टली सेम जो ऑब्जेक्ट्स है अपोजिट साइड में जा रहे हैं, like my thumb, like my finger. It is the example of enantiomer. So what are the enantiomer? The optical isomerism in which object and mirror image are non-superimposable to each other, and it is called as enantiomer. So best example, 2-chlorobutane. This is object, this one is your mirror image. Now so far in this lecture we have covered 5 basic and important concepts, and now we will come to the point optical activity. So students, hope you will understand what is stereoisomerism. Just go through your 11 textbook. Then what is chiral carbon, जिसको 4 different items attach रहेंगे, groups attach रहेंगे, वो कार्बन को अपन बोलेंगे chiral carbon. Chiral molecule जिसमें chiral carbon रहेगा, और वो क्या रहेगा, नॉन सुपर इम्पोजेबल, दैट इज योर chiral molecule. What is your optical isomers or optical isomerism? Different spatial arrangement of atoms or group around chiral carbon is called as optical isomers. And related to optical isomers, next concept is given enantiomer. What are the enantiomer? So the optical isomerism or isomers in which object and mirror image are non superimposable to each other, it is called as enantiomer. Now we are going to come our main concept of topic and last point, optical activity. Now before going to start optical activity, let me discuss the characteristic of enantiomer. What are the characteristics? Now enantiomers have same molecular formula. Enantiomers have same molecular formula. Both are the example of 2-chlorobutane. लेकिन दोनों में difference क्या है? They are non-superimposable. So enantiomers have a same physical properties. First characteristic of enantiomer क्या है? Enantiomers have a same physical property. Enantiomer have a identical chemical property. Enantiomers have a identical chemical property. Okay, these are the properties of enantiomers. Same physical properties, say identical chemical property, except sign of rotation. That we will discuss in optical activity. After 2 or 5 minutes, मैं double से repeat करूंगा what are the characteristic of enantiomer. Okay, so our next point in case of optical activity is plane polarized light, and now from here we will start our concept what is optical activity. Student, our point is plane polarized light. When ordinary light, this is a cross section of ordinary light. अब ordinary light travels in all direction, vibrates या oscillation in all direction. Ordinary light oscillation in all direction. अब उसको अपन कैसा शो करेंगे? See, this is the direction oscillation of ordinary light which vibrates, travels in all direction, which oscillates in all direction. So this is the cross section of ordinary light. When this ordinary light pass through a nickel prism, when this ordinary light pass through a nickel prism, अब ये light which oscillates in all possible direction, which vibrates in all possible direction, अपन इसको किसमें से पास कर रहे हैं? पास through a nickel prism, oscillation only in one plane emerge out. Oscillation only in one plane. अब oscillation only in one plane means you will get like this. Now here ordinary light oscillation in all possible direction. When it pass through a nickel prism, oscillation only in one plane emerge out, and such light having oscillation in only one plane perpendicular to the direction of propagation of light, this is called as plane polarized light. When ordinary light pass through a nickel prism, oscillation only in one plane emerge out, and such light having oscillation only in one plane is called as plane polarized light, perpendicular to the direction of propagation of light. Now see here, oscillation in all possible direction. अब जैसे निकोल प्रिज्म में से पास हो रहा, so ये oscillation क्या हो जा रहा? Only in one plane. So this light is called as a plane polarized light. When this plane polarized light pass through organic substance. Now suppose this one is your tube containing aqueous solution of organic molecule. Aqueous solution of organic molecule, organic compound, say sugar, lactic acid, aqueous solution of organic molecule or organic compound. When the aqueous solution of organic compound like sugar or lactic acid is placed in the path of plane polarized light, अब ये जो प्लेन पोलराइज्ड लाइट है उसको मैं किस में से पास कर रहा हूं? ऑर्गेनिक कंपाउंड में से. द प्रॉपर्टी ऑफ दिस सब्सटेंस, द प्रॉपर्टी ऑफ दिस सब्सटेंस टू रोटेट, property of this substance to rotate the plane of polarization of incident plane polarized light. Property of this substance to rotate plane of polarization of इंसिडेंट प्लेन पोलराइज्ड लाइट. अब प्लेन ऑफ पोलराइजेशन ऑफ इंसिडेंट प्लेन पोलराइज्ड लाइट का मतलब क्या होगा? जैसे ये प्लेन पोलराइज्ड लाइट ये सब्सटेंस में से, एक्वियस सॉल्यूशन के सब्सटेंस में से पास होगा, ये सब्सटेंस क्या करेगा कि ये प्लेन पोलराइज्ड लाइट को रोटेट करेगा. नाउ दिस इज द पाथ ऑफ प्लेन पोलराइज्ड लाइट, ये पास हो रहा. अब जैसे यहां से यहां तक आया हो, अब ये सब्सटेंस उसको रोटेट कर रहा, आइदर क्लॉकवाइज डायरेक्शन or anti-clockwise direction. If it rotate in clockwise direction, so our new oscillation will be like this. Now this is the plane. Now it rotate in clockwise direction. If it rotate anti-clockwise direction, so we will get oscillation like this. And this property of substance is called as optical activity. The compound which rotates the plane of plane polarized light to right or left. Right means clockwise direction and left means anti-clockwise direction, and such compounds are called as optically active compound, and that is my topic. So what is optical activity? What is plane polarized light? That is important. So what is plane polarized light? When ordinary light pass through a nickel prism, okay, oscillation only in one plane emerge out, and this light is called as a plane polarized light. And when aqueous solution of organic compound placed in the path of plane polarized light, the property of this substance rotate the plane of polarization of incident plane polarized light in clockwise direction or in anti-clockwise direction, right or left, and such compounds are called as optically active compound. And the compound which do not rotate the plane of plane polarized light, right or left, clockwise or anti-clockwise direction, such compounds are called as optically inactive. जो रोटेट करेगा उसको अपन क्या बोलेंगे, ऑप्टिकली एक्टिव, और जो रोटेट नहीं करेगा that we will say it is optically inactive. And this is our today's topic, that is optical activity. Okay, so the property of substance to rotate the plane of polarization of इंसिडेंट प्लेन पोलराइज लाइट, जो भी लाइट इसमें से ट्रांसफर होंगी, ट्रांसमिटेड लाइट को बोलते हैं इंसिडेंट प्लेन पोलराइज लाइट टू राइट clockwise direction or left anti-clockwise direction, and such compounds are called as optically active compounds. Now here two types of rotations are there. One is your clockwise direction, another one is your anti-clockwise direction. Now the property of, or we can say optical activity, it is measured in terms of optical rotation. Experimentally it is measured in terms of optical rotation. Actually optical rotation means angle through which the molecule, the substance rotates the plane polarized light. कितने डिग्री पर उसने प्लेन पोलराइज्ड लाइट को रोटेट किया, that angle is called as optical rotation. What is the optical rotation? The angle through which substance rotates the plane of plane polarized light towards right or left, clockwise or anti-clockwise, that angle is called as optical rotation. So optical activity is experimentally measured in terms of optical rotation, that is theta, angle is given to you. Now after that 2 points are given. One is your dextrorotatory, it is represented by D or symbol plus, and second one is your leorotatory. Leorotatory, it is represented by small l or sign used is negative. Now students, here I have shown to you ऑप्टिकली एक्टिव सब्सटेंस रोटेट्स द प्लेन ऑफ प्लेन पोलराइज्ड लाइट, जो एक ही डायरेक्शन में रन कर रहा था उसने उसको रोटेट किया, आइदर क्लॉकवाइज और एंटी क्लॉकवाइज. वी आर सेइंग सच कंपाउंड्स आर ऑप्टिकली एक्टिव. द कंपाउंड व्हिच रोटेट्स द प्लेन ऑफ प्लेन पोलराइज्ड लाइट इन क्लॉकवाइज डायरेक्शन, right hand side, such compounds are called as dextrorotatory compound. What is dextrorotatory compound? The compound which rotates the plane of plane polarized light clockwise direction, right hand side, it is called as dextrorotatory, and it is designed or it is represented by symbol small d or plus sign. Now what is leorotatory? L-A-E-V-O, the compound which rotates the plane of plane polarized light anti-clockwise direction. Compound which rotates the plane of plane polarized light anti-clockwise direction, left hand side it is called as leo, and right hand side it is called as dextro. Okay, leo, it is represented by small l or it is represented by negative sign. So these are the concept related to optical activity. So in short अपन optical activity किसको बोलेंगे? So the property of substance which rotates the plane of polarization of इंसिडेंट प्लेन पोलराइज्ड लाइट टुवर्ड्स राइट और लेफ्ट. अगर उसने राइट रोटेट किया, दैट कंपाउंड इज कॉल्ड एज डेक्स्ट्रोरोटेटरी, एंड इफ इट रोटेट टू लेफ्ट हैंड साइड एंटी क्लॉकवाइज डायरेक्शन, इट इज leorotatory. Now after this concept, dextrorotatory, leorotatory, what is optical activity? Next part of our discussion, that is Racemic modification, या what is Racemic mixture. Racemic modification or what is Racemic mixture. Okay, modification or Racemic mixture. Now here we have discussed, one is your dextrorotatory and second one is your leo. Now dextrorotatory plus sign and leo, it is represented by minus sign. Actually Racemic mixture means equimolar quantities of two opposite rotatory substance. Equimolar quantities of two opposite rotatory substance. अब equimolar quantities of two opposite rotatory substance मतलब क्या रहेगा? Dextro and leo, and it is represented by Dl or plus minus sign. So what is your racemic modification? Racemic mixtures are equimolar quantities of enantiomers. Equimolar quantities of enantiomers are two opposite rotatory substance. It is called as racemic mixture. Suppose here 2-chlorobutane. See, just before 10 minutes मैंने यहाँ draw किया था. What is 2-chlorobutane? Now this is the structure of your 2-chlorobutane. This carbon is your asymmetric carbon. Okay. Now these two act as a enantiomer. These two act as a enantiomer. Okay. Now this is the structure of stereo structure of 2-chlorobutane. Now this is your thick line C2H5, broken line or dotted line, that is your hydrogen. Now if one is D, second will be L. If one is dextro form, second will be Leo form. And mixture of these two, that is dextro and Leo, this mixture is called as racemic mixture. And racemic mixture, it is always optically inactive. Racemic mixture is always optically inactive. Why racemic mixture is always optically inactive? क्यों रहेगा ये optically inactive? Because rotation, one rotation is cancelled by another rotation. Rotation, or we can say enantiomer rotation of molecule is cancelled by another rotation, because it is a mixture of plus and minus. Plus minus get cancelled, and that's why it is optically inactive. So always try to remember, one rotation is cancelled by another rotation, and that's why racemic mixture is optically inactive. And these two are act as enantiomers, optical isomers, which are non superimposable to each other, are called as enantiomer. And student, this is all about a concept, optical activity. So first point, chiral carbon. Carbon in a molecule which carries 4 different atoms group around it called as chiral carbon. Second, chiral molecule. What is chiral molecule? If molecule contain any one chiral carbon, such molecule cannot be superimposable. It will be non-superimposable perfectly, and this molecule is called as a chiral molecule. Second one, here optical isomers. Stereoisomerism, in which isomers have different spatial arrangement of atoms or group around chiral carbon. Around chiral carbon is called as optical isomers. Then what is enantiomer? So the optical isomers, okay, which are non-superimposable mirror images of each other, called as a enantiomer. Then what is plane polarized light? When ordinary light oscillation in all direction, चारों तरफ फैलती है वो, pass through a nickel prism, oscillation only in one plane emerge out, and this one plane oscillation, it is called as plane polarized light. Next one, what is optical activity? So the property of substance to rotate the plane polarization of incident plane polarized light. अब वो जो लाइट एक ही इसमें वाइब्रेट कर रही थी, उसको वो रोटेट करता, एंगल चेंज करता उसका, आइदर क्लॉकवाइज डायरेक्शन और एंटी क्लॉकवाइज डायरेक्शन. अगर क्लॉकवाइज डायरेक्शन में रोटेट किया, दैट इज योर डेक्स्ट्रो रोटेटरी कंपाउंड. इफ रोटेट anti-clockwise direction, it is Leo rotatory. Dextro rotatory, it is represented by D. Leo rotatory, it is represented by L. Okay, and the equimolar mixture of two opposite rotatory substance. अब two opposite rotatory substance का मतलब रहेगा, one is dextro clockwise and another one is Leo anti-clockwise. That is called as your racemic modification. So now one effect means one rotation is cancelled by another rotation, and that's why racemic mixture is always optically inactive. And what are the characteristic of enantiomer? So enantiomers have a same physical properties. Now physical property means its boiling point, melting point, density, दोनों का भी boiling point same रहेगा, because molecular formula is same. melting point same रहेगा, density will be same, refractive index will be same, but the sign of rotation will be different. अब sign of rotation will be different का मतलब क्या रहेगा? One will be positive clockwise and another will be negative anti-clockwise. Now enantiomers have identical chemical properties, okay, except towards optically active reagents. Okay, so these are the properties of enantiomer, and this is all about your concept optical activity. Hope you will understand this point. Now in next video we will try to cover the nucleophilic substitution reaction of alkyl halides. Thank you.